Hello class. Today we are looking at counting techniques. We're in section 5.3, page 225. And you have three count techniques we're going to talk about today. We're going to talk about factorial notation, which is on page 225. We're going to talk about counting rules for permutation, which is on page 226, and then the counting rule for combinations, which is on page 227. Very important that you look at that. And then you do have your procedures on how to determine the number of outcomes of an experiment at the bottom of page 227. So very important that you read pages 225 through 227. We're going to start off with the factorial. A factorial, you will see a exclamation mark. So I'm just going to do a few examples to show you how to break down factorial. Very, very easy. And you do have to apply the operation, multiplication. So again, I always tell students that when in doubt and you don't know what operation to use, it's usually multiplication. So we're going to start with an easy one. Then we're going to work our way to a few more challenging factorials. We're going to start off with 3 factorial, and that is how you read it, 3 factorial. 3 factorial just means that you start with the number given and you count down to 1. So I have 3 times 2 times 1. Of course, we don't say 0 because we say 0, every answer will equal 0. So you stop at 1. We know 3 times 2 is 6 times 1 equals 6. So 3 factorial equals 6. That is it. Another example. What if I have 3 times 5 factorial? So right here, 3 is not connected with a factorial. So you just write down 3. And we're going to break down 5 factorial. We're going to say 5 times 4 times 3 times 2 times 1. So you just count down to 1. You do have your calculator. So type those numbers in. And you should get 360. Let's try one more factorial example. What if I have one that says 5 factorial divided by 2 factorial times 3 factorial? We're going to break it down as usual. We're going to say 5 times 4 times 3 times 2 times 1 divided by, we have 2 factorial, so we're going to have 2 times 1. Then we have 3 factorial, so he said times 3 times 2 times 1. Now, we do know that we can cancel out. The 3's cancel out, the 2's cancel out, and the 1's cancel out. And it doesn't matter how you cancel as long as you cancel one at the top and one at the bottom. So if I wanted to cancel out the denominators, the first 2 and 1, I could have done that. That would have been fine. So make sure that you are canceling out properly. You are to multiply what is remaining. I see 5 times 4, which is 20. 2 times 1 is 2. Simplify that answer, and my answer is 10. That is how you do a factorial. Very easy. Factorials are very important because we use factorials also when we're looking at permutation and combination problems. So a permutation problem, you have the permutation n taking 4 at a time, 10, n taking r at a time, and that formula equals n factorial divided by n minus r factorial. So what is n and r? N and r can be a case like if I have 10 members in a club and I want to select 4 people in a officer position. So my n would be my entire group, which is 10 people, and the people I want to select as officers will be my r, which is 4. So n taking 4 at a time. So n represent the entire group, and r would be the group that you're taking out. Another thing about permutation is that the order does matter. So just a really simple example. If I tell my students, I may tell students line up from shortest to tallest person. The order matters. Okay, so permutation, we know that the order matters. P-O, order matters. Now, we're just going to do some problems. If you run across some word problems, you do want to pay attention to what it says. If the order matters, you use permutation. if the order does not matter, and that's a case of me telling you all, class, just line up. It doesn't matter how you line up. I just want you to line up. That would be a combination problem, C, D. Combination does not matter. So if you run across certain word problems, if the order matters, you use permutation. If the order does not matter, you will use a combination. And the forms are different, but we still use the N and the R the same way. N is the entire group, R taken at a time. Let's look at a permutation problem, and we're going to go through the whole process. I have the permutation of 5 taken 2 at a time. So we know that N is my 5 and R is my 2. So that first number is going to be your N. That second number is going to be your R. Going back to the formula, the formula has N factorial. So we're going to say 5 factorial divided by N again minus my R factorial. Work out your math. 5 factorial we know is 5 times 4 times 3 times 2 times 1 divided by, we know that 5 minus 2 is 3. So 3 factorial would be 3 times 2 times 1. So again, we know that the 5 minus 2 will give me that 3 factorial, which I counted down to 3 times 2 times 1. You want to cancel out again. So do not multiply all that out. Cancel out and then multiply. So my answer for my permutation for 5 taken 2 at a time is 20. And that is how you would do that problem. Let's look at a combination problem. So the formula for combination is a little bit longer. So we have a combination of N taken 4 at a time. And that formula is N factorial divided by R factorial times N minus R factorial. So it's a little bit longer, one extra step. And with combination, we know that the order does not matter. CD does not matter. We have the combination of 7 taken 4 at a time. Take it back to my formula. We have N factorial, which is 7, and my R is 4. N factorial, so we have 7 factorial divided by R factorial, so that would be 4 factorial, times N minus R again, which is 7 minus 4 factorial. And we go through the math again. We're going to count down that 7. 7 times 6 times 5 times 4 times 3 times 2 times 1. Break down that 4 factorial. 4 times 3 times 2 times 1. And we know that 7 minus 4 will give me that 3 factorial. So you're going to break down 3 factorial. So times 3 times 2 times 1. You're going to cancel out everything you see. I see some 3s, I see 2s, I see 1s, and then I also see a 4. So we have everything canceled out. We multiply what is remaining. 7 times 6 times 5 is 210. Divided by 3 times 2 times 1, which is 6. 6 divided by 210 should give me 35. And that is how you work out a factorial, permutation, and combination. I do want to look at some calculator practice on Desmos. If you have your TI-84 plus CE, I'm going to just talk you through it. So if you do have that, you want to take that out so I can talk you through it. If you have a TI-84 plus CE, I would first click on Math. and that's going to be the left-hand side of your calculator. Then you're going to move your arrowhead to the right. One, two, 3 times. You're going to move it 3 times until you see the PROB. And then on there, you will see a NPR, which is number 2. You will see NCR, which is number 3. And you will see a exclamation point, which is your factorial, which is the number 4 on your button. So the way you would do that is, I would say for instance, I want to do the P52 again. I would say 5 on my graphic calculator, math, move it to PROB, press number 2, and then I would type in the number 2 after that and then enter, and it will give me my answer, which is 20. So when you're doing the permutation combination problem on your graphic calculator, you type in your N first, then you identify if it's a permutation or a combination problem. Then you write in your R, and then you hit enter, and it will give you your answer. So you have a calculator, listen to what I'm saying, look at what I wrote, and practice. If you do not have a graphic calculator, that is okay. Look at it on Desmos, the scientific calculator, which is great. And this one's just a little less complicated because I don't have to do the N, then the P, then the R after that. I don't have to do it that way. I can type it in just like I see it on my paper. If I want to find the permutation, I'm going to go to function. And at the very bottom left, I see an NPR. I'm going to hit that button. And then I'm going to type in my 2 values. I'm going to say 5, 2. And if you see, they gave me 20. And I have my answer. It's that simple. Let's try the combination one. So we're going to clear all. I'm going to go to function again. And if you look at the bottom left again, it says NCR. And I'm going to type in, go back to main, so you can get back to your numbers. I'm going to say 7, 4. And it gives my answer, which is 35. If I want to do a factorial, let's clear all. I'm going to do 7 factorial. So I'll say 7, go back to function. And then you see an exclamation point at the bottom left too, and it will give me my answer, 5,040. So 2 ways you can do it. You know how to do it on your TI-84 CE Plus graphic calculator, and you also know how to use it on Desmos. You know how to work it out by hand and use it on your calculators. Remember what I said, permutation, the order matters. Like, it's almost like me telling you to line up from shortest to tallest. Combination, the order does not matter. It's me telling you just line up. So very important that you remember those rules. And make sure you go back and read over these formulas in your textbook. Any questions or concerns, please let me know.